short answer, anchored uh, to anchor you. Your LiveKit plus Firebase app does not send protobufs from Next.js to Firestore. Firestore do not accept protobuf payloads from your app code. Instead, LiveKit uses protobuf internally over gRPC or WebRTC signaling. Firestore uses protobuf internally on Google Server. Your Next.js or browser code sends JSON-like JS objects. The Firestore SDK translates those objects, protobuf, to gRPC. You never manually encode or decode protobuf. Now let's unpack this byte by byte. Layered mental model. This fixes everything. Think in 5 layers, not one. Browser to Firebase Web SDK JS to http//2/web channel/gRPC like transport to Google Firestore front end servers to Firestore storage engine. Inside we have LSM/SS table/M tables. LiveKit is parallel, not inside this pipeline. Where protobuf actually lives in your app. A. LiveKit. This one does use protobuf. LiveKit uses protobuf in two places. First, signaling, room join, tracks participants. Protobuf messages sent over WebSocket or WebRTC data channels. Binary encoded. Example, conceptual, not your code. Message join request, open semi-curly bracket, next line string room equal 1, semicolon, next line string token equal to semicolon, then next line closing semi-curly bracket. The browser does not see this as JSON. It's binary frames. Second, media or control plane. RTP packets binary, SETP for data channels, completely unrelated to Firestore. This is true protobuf usage. Firestore is not involved. Firestore, this one hides protobuf from you. Firestore uses protobuf internally, but you never touch it directly. Second, what your Next.js or browser actually sends. When you do this in your app, await set doc, inside parameter db, quote room ID, closing parenthesis, open semi-curly bracket, then inside is we have title, key value title weekly sync, next line key value created at server timestamp, open and close parenthesis, next line key value participants 4, closing semi-curly, closing parenthesis, semicolon. What you think happens? I'm sending JSON. What actually happens? First, you create a JavaScript object. Second, Firebase SDK, validate types, and then converts it to Firestore value format. Third, SDK realizes it into protobuf, serializes it into protobuf. Fourth, protobuf is sent via HTTP/2 plus gRPC-like framing or web channel browser safe gRPC. You never see step 3. Third, Firestore's internal protobuf, very important. Firestore internal API looks like this, simplified. Message write request, open semi-curly, inside this, repeated writes equal 1 semicolon, closing semi-curly bracket, then message write open semi-curly, next line string update underscore path equal to 1 semicolon, next line document update equal to semicolon, then closing semi-curly bracket, next line message document opening semi-curly, next line string name equal 1 semicolon, next line map, inside string value, then fields equal to semicolon, closing semi-curly bracket, and values, message value, open semi-curly, next line one of kind, open semi-curly, next line string underscore value equal to 1 semicolon, next line int 64 integer underscore value equal to semicolon, next line timestamp underscore value equal 3 semicolon, then closing semi-curly bracket, then closing semi-curly bracket. So Your JS object is open semi-curly bracket, key value title, colon weekly sync, comma, key value participant, colon for closing semi-curly bracket, becomes conceptually fields, opening semi-curly, then next line key value key, colon, code title, then next line value, opening semi-curly bracket string underscore value colon quote weekly sync closing semi-curly next line fields opening semi-curly next line key value for key colon quote participants next line value opening semi-curly integer underscore value colon for closing semi-curly. How listeners work? This connects to LSM trees and mem tables. When you do on snapshot parameter query comma callback, what happens? First, SDK sends a listen request, protobuf. Second, Firestore server checks mem table, checks SS tables, applies indexes. Third, server sends document change protobuf messages. Fourth, SDK decodes protobuf to JS objects, calls your callback. You receive opening semi-curly bracket, next line doc changes colon opening semi-curly bracket, next line opening semi-curly bracket, type colon, quote added, comma, doc colon, opening semi-curly bracket, dot closing, and then closing parenthesis, closing square, and then closing semi-curly bracket. You never decode protobuf yourself. Browser never sees binary blobs. Where Next.js fits, this clears a big confusion. Does Next.js listener send protobuf to Firestore? No. Browser, Firebase Web SDK, uses web channel/HTTP, encodes protobuf internally. Next.js server, Firebase admin SDK, uses real gRPC, encodes protobuf internally. But in both cases, you write JS objects, not protobuf. 6. Next.js to Firestore to browser, full path. Let's do a real flow from your app. Example, create room, browser, await fetch, quote, /API/create room, comma, opening semi-curly bracket, next line method, colon, post, comma, next line body, colon, JSON.stringify. Open parenthesis, open semi-curly name, colon, code, daily stand up, closing semi-curly, closing parenthesis, closing semi-curly, closing parenthesis, semicolon. Next.js API route, await admin.firestore, open and close parenthesis, dot collection, quote rooms, dot add, opening parenthesis, opening semicolon, next line name, key value name, colon, daily standup, comma, key value created at, colon, field value, that server timestamp. Closing semi-curly bracket, closing parenthesis, semicolon. Under the hood, it's JS object to admin SDK to protobuf encoding to gRPC HTTP/2 to Firestore frontend to memtable write. Browser listener wakes up. Memtable updated to listen stream the text change to protobuf document change to SDK decodes to JS to React renders. Where LSM trees concepts feed from previous messages inside Firestore's servers. Writes go to memtable. Memtable reaches threshold. Flash to SS table. SS tables are immutable. Compaction merges files. Index block stays in memory. Data blocks may be compressed. Your app never sees this, but your read latency is affected by it. This explains cold versus warm reads, listener speed, repeated reads hitting RAM. Why you see JSON in DevTools, not protobufs? In Chrome DevTools, Firebase SDK unwraps everything. Shows you decoded JS objects, network tab hides binary framing. So you see, open semi-curly bracket, key value fair quote name, colon, quote daily standup, closing semi-curly bracket, even though protobuf was used underneath. 9. IndexedDB, Cache, and Firestore SDK. Disconnect to your application tab. Firestore Web SDK uses IndexedDB. stores recent documents, pending writes, resume tokens, enables offline mode, explains why repeated reads are instant, listeners recover after reload. This is client-side cache, not server main table. Final mental model, final mental separation, very important. Layer, LiveKit signaling, encoding, protobuf, you control it now. Layer, Firestore SDK, encoding, protobuf, you control it now. Layer, browser to SDK, encoding JS objects, you control it now. Layer, next.js code, encoding JS objects, you control it, yes. Layer, Firestore storage, encoding LSM plus SS tables, you control it now. One sentence summary, burn this in. You never send protobuf to Firestore. You send JavaScript objects and the Firebase SDK silently convert them into protobuf over gRPC, while Firestore stores them using an LSM trees and serves the coded objects back to your listeners. First, let's fix one critical misunderstanding. This unlocks everything. So I only use JSON to convert the JS objects to be sent via gRPC or HTTP2? No, JSON is not involved past your own app boundary. JSON exists only where you explicitly call JSON.stringify or receive HTTP response you created yourself. Firestore never sends JSON over the wire to the browser. What you see as JSON is actually protobuf to JS objects to DevTools pretty printing. That's the key illusion. First, what JSON.stringify actually does, very important. This line await fetch code /API /create room, comma, opening semi-curly bracket, next line method, colon, code post, comma, next line body, colon, JSON.stringify, open parenthesis, open semi-curly bracket, name, colon, code, daily stand up, closing semi-curly bracket, code, closing parenthesis, closing semi-curly, closing parenthesis, semicolon. This is JSON. This JSON is only for browser, your own next.js API route, plain HTTP request body, nothing to do with Firestore. On the server, we have const body equal await rec.json. Now you have a JS object again. After that point, JSON is gone. Firestore never sees it. Where protobuf actually starts. Browser, Firestore SDK. When you do set doc, open parenthesis doc, open parenthesis db, comma, code rooms, comma, id, closing parenthesis, comma, opening semi-curly bracket, name, colon, codes, daily stand-up, closing semi-curly bracket, closing parenthesis. What happens? JS objects to Firestore SDK client side, to internal protobuf message construction, to binary serialization, to HTTP/to web channel. There is no JSON encoding step here, but I see JSON responses in DevTools. This is the illusion. What actually happens? First, Firestore sends binary protobuf frames. Firebase SDK decodes protobuf into JS objects. Third, Chrome DevTools displays JS objects as JSON-like structures. DevTools is not showing the network payload, it's showing the SDK's decoded output. If Chrome showed raw protocol bytes, you'd see something like 0A space 2F space 70 space 72 space 6F space 6A space 65 space 63 space 74 space 73 space 2F, which will be useless to humans. Who converts protobuf to JS objects? The Firebase SDK does. Browser uses web channel gRPC like streaming over HTTP/2. Protobuf compiled to JS classes decodes binary to JS objects. Admin SDK Node.js uses real gRPC. Protobuf compiled to Node bindings decodes binary to JS objects. You never call this directly, but it exists. So is there ever protobuf to JSON conversion? Only in two cases. First, you explicitly serialize JSON.stringify open parenthesis doc.data. Second, DevTools UI representation, Firestore itself, protobuf to JS object, stops there. No JSON conversion internally. Why is this hard to imagine? You're not wrong. Because JSON is visible. Protobuf is intentionally invisible. SDK at abstract transport plus encoding. You're seeing decoded state, not wire format. This is the same reason you don't see TCP packets in fetch. You don't see syscalls in fs.read file. Where IndexedDB fits client-side cache. This is important for your confusion. Firestore Web SDK uses IndexedDB to store documents, query results, resume token for listeners, pending writes, offline support. This explains repeated reads equal instant, reload page equal data still there, listeners resume without refetching everything. This IndexedDB is created by Firebase SDK, structured internally. You don't define schema, not related to Firestore server indexes. Can you delete IndexedDB manually? Yes. In Chrome DevTools, application to IndexedDB to Firebase, then right-click delete or programmatically debug only index.db delete database code Firebase local storage DB. Never do this in production code. Can you control Firestore caching behavior? Yes, but only at SDK level. Like this code, initialize Firestore, open parenthesis up, comma, open semi-curly bracket, next line local cache, colon, persistent local cache, open and close parenthesis, closing semi-curly bracket, closing parenthesis, or disable persistence. Disable network DB semicolon, but you cannot control mem tables. You cannot control SS tables. You cannot control compaction. Those are server side. Is Firebase SDK universal? Yes, but only the admin SDK. Let's separate environment browser, SDK Firebase Web SDK. Environment versus server, SDK Firebase admin SDK. They do not talk to each other directly. Both talk to Firestore servers. 11. How Firestore stores protobuf, LSM3. Firestore server side. Protobuf document to write ahead log to mem table skip list to flash to SS table sorted comma immutable to compaction indexes also LSM based not B3s. 12. Why Firebase choose LSM over B3? This answers a big earlier question. Firestore workload characteristics. Many small writes, high write concurrency, append heavy, global replication, streaming listeners. LSM advantages, sequential disk writes, high write throughput, efficient replication, better for append-only workloads. B3 problems here, random writes, lack contention, poor for write-heavy distributed systems. Firestore is closer to Big Table than MySQL. Mapping network tab to Firestore listen streams. Those requests like channel question mark var equal 8 and dot database equals project slash dot r web channel streaming connections long live carry protobuf frames used for listeners auto refresh resume tokens. That's your real-time listener transport. Where LiveKit fits in all these? LiveKit protobuf to WebRTC independent pipeline uses Firestore only for metadata, rooms, users, permissions. Media does not touch Firestore. Are you asking the right question? Yes, 100%. The real question you're asking is where does abstraction end and where does the system actually run? That's the question of senior engineers and system designers. Final mental map. Your code, JS objects to Firebase SDK to protobuf binary to HTTP /2 gRPC to Firestore front end to LSM3 mem table plus SS tables plus to compaction to reverse path to SDK decodes to JS objects to React. Is Firestore data still protobuf during compaction? Yes, protobuf all the way down. Firestore never converts data to JSON internally, not even during compaction. Internal lifecycle simplified but accurate. Client JS object to protobuf message to write ahead log protobuf in the Firestore side to memtable, which have protobuf fields, comma, structured in memory, to SS table blocks, protobuf encoded values to compaction, merge protobuf blocks to new protobuf blocks. Compaction reads already encoded protobuf values, merges / drop obsolete versions, write new SS table still containing protobuf. There's no decode to encode round trip during compaction. That would be too expensive. Protobuf is both wire format and storage format. That's a key design decision. Is protobuf already binary enough for storage? Yes, that's actually why the database like Firestore use it. Protobuf gives compact binary encoding, schema evolution, add field safety, fast decode, no parsing like JSON, stable byte layout, important for storage. Firestore may still apply, block compression, ZSTD/snappy, and prefix compression for keys in its indexes. But that's compression on top of protobuf, not instead of it. Does Firestore use HDD or SSD? Firestore runs on Google's production storage stack, which today means SSD block distributed storage. Log structure design optimized for SDD, replicated across zones. Historically, big tables started on HDD. Modern Firestore is SSD first. Why this matters? LSM trees plus SSD equal very high throughput. Sequential writes dominate. Flash gamma compaction. Does LiveKit also store protobuf? Yes, but for different reason. LiveKit uses protobuf for signaling, control messages, session state, room metadata in memory, or optional in disk, but not for media. Media does not touch Firestore. What really means? This sentence is critical. Firestore is not in the media path. Your LiveKit app has two planes. Control plane, Firestore, users, rooms, permission, metadata, UI state, present, sometimes. This is low bandwidth, structured transactional data. Firestore is perfect here. Media plane, WebRTC, audio frames, video frames, screen share, data channels, binary streams. This is high bandwidth, real-time, UDP-based, no persistence. Firestore would be catastrophic for this. So Firestore messages to protobuf to JS objects. WebRTC media to RTP packets to the calls to GPU/audio devices. They never intersect. Firestore tell you who and what. WebRTC carries the actual media. Where abstraction actually ends, important mental anchor. Let's draw the true boundary. Abstraction ends at bytes handed to the OS kernel. Everything above that, SDK abstractions, protobuf objects, JS objects, query APIs. Everything below that, syscalls, page cache, SSD firmware, network NICs, and other low-level firmware or driver. Firestore server is a normal user space process running on Linux using syscalls like write, pread, mmap, fsync. The magic is engineering, not a different universe. Will reading Firestore proto definition help or confuse you? Honest answer, both, but in a good way. Proto files are low-level, verbose, mechanical. They won't explain why immediately, but they will answer what fields exist, what is stream, what is cache, what is mutable versus immutable. Given your questions, you are ready, especially if you read with a goal, read them with a goal, not randomly. Show how IndexedDB mirrors Firestore query results. This is big. This happens entirely in the browser. When you run on snapshot, parameter query, parameter collection, parameter db, quote rooms, closing parenthesis, the web SDK does send request to server, then initial batch of documents, then that SDK writes docs into your IndexedDB, the document key field decoded from protobuf update time before it actually returns docs to your callback. Now, IndexedDB holds a local mirror. Query results are keyed by collection, filters, order by. When page reloads, network drops, listener resumes, SDK reads IndexedDB first, renders UI immediately, sync deltas from server afterward. That's why your app feels instant. Repeated reads are RAM speed. You see all data before network completes. IndexedDB is approximately equal to client-side SS table but mutable and smaller.